Hello everyone and welcome to my video tutorial on Introduction to Computer Programming using Python Part 1. This is the 9th class of the series, Functions. The objective of the class today is to learn about functions in Python. Motivation. Functions are a foundation of structured programming and modular design, topics we are going to learn about today. Therefore, it is important for the aspiring programmer to understand functions thoroughly and know how to use them in development. Content: Introduction to functions, function definition, basic function definition, arguments and parameters, positional arguments, keyword arguments, default values, equivalent function calls, function return values, optional arguments, returning a dictionary, function in a while loop, passing a list, modifying a list, passing an arbitrary number of arguments, using arbitrary keyword arguments, storing functions in modules, importing modules in programs, various ways of importing modules in programs, styling functions. Learning outcomes. At the end of a class, the participants should be able to describe a function in Python and describe its associated terminologies or define them. Define and call functions. Pass data to functions. Get data from functions. Use functions in loops. Create and use function modules. Introduction to functions. What is a function in programming? It is a named block of code designed to do some specific job. It can also take an optional list of arguments if required. Let's describe it this way. Since we have been writing our programs, we have been using some built-in functions that were created in Python to make our programming easier. For example, input, print, all of those are built-in functions. So modular programming is like this. It is a good way or a better way to create your software in something called blocks of modules. Let's take an analogy. Suppose your car, your computer, or any machine you use was made up of a single block. Everything is welded together. You cannot remove a part, you cannot change a part if it is faulty. So what happens if something gets bad in your computer? For instance, if your keyboard was welded to your computer or your laptop. What happens if the keyboard gets bad? You throw away the whole of the computer and buy a new one. If the carburetor in your car gets bad, or the wheels of your bicycle gets bad, what do? You throw away the whole item and you get a new one. That is inefficient. So, normally systems are created from different parts, different manufacturers. I can assure you that if you open your computer, you'll discover that the Dell computer or the Lenovo computer I'm using right here, everything in the computer did not just come from Lenovo, produced by Lenovo. There were many different parts that came from different places. For instance, the processor may have come from Intel or AMD or some other company. The keyboard may have come from somewhere else. I'm having a JBL speaker on this system, so it came from JBL. The drive may have come from Seagate or somewhere. The RAM modules, memory modules may have come from somewhere else. So these are modules that the company puts together to actually create a computer for us. The same way with your car. The carburetor is a part, the engine block is another part, the crankshaft is another part, so on and so forth. The windscreens, the doors, the seats, see? All of them did not come from one manufacturing machine. For instance, the tires are made of rubber. It's a different machine entirely which produces the rubber. Another different machine produces the engine block, so on and so forth. So that's what functional programming is about. We are going to create our software in such a way that several problems related to the software are created as modules, sub-modules that can accept input and output. So you just create a module as a block and somebody can use it. It receives an input and it produces an output. For instance, your carburetor receives fuel and produces an output. If you go to Google and type how many programmers or developers contributed to the design of Windows 11 or Windows 10, you will be surprised. Many developers, probably spread across the world, all of them working together on one system. How did they do that? By modular programming or functional programming. So this is a very important topic. Whichever programming language you learn, is like JavaScript, C, C++, you have to do functional programming. And this is very good. When you learn how to use it and know how to use it, you will fall in love with it. So like I was saying before, a function is a named block of code that is designed to do a specific job. It can also take an optional list of arguments if required. Recall Python built-in functions, we have been using them. So we want to create our own. Steps to creating and using functions. You must define a function. This must be done first. Function definition. And the second part is you must call the function whenever you want to use it. Functions make your programs easier to write, read, test, and fix. You write less lines of code if you know how to use functions. You make your programs very elegant if you know how to use functions. Your programs become readable, more testable, and more fixable, in the sense that when something is wrong with your program and you perform a diagnosis and you discover that the fault is in one function, you just take out that function and fix it. It's like picking up a part of your car or your machine and then going to fix it. So I remember how many things I have fixed in this laptop after using it for years. I've fixed the screen twice, the keyboard once, and I have replaced the battery once. So that's what we mean by modular design. So modular programming also facilitates shareable modules. If you write a function, you can give it to your friend. If you work in a company, in a group, you can design functions, put them somewhere so that whenever you want to create a new software, you can look at the usable functions that are applicable to the new software you want to write. Just pick them up, then you use them. So if you have been doing any embedded programming, you discover that in embedded systems programming, you have to do a lot of things yourself. You have to write a program for the keyboard, for your system to accept data from the keyboard. You have to write a program for your system to take the data and put it on the screen. And that's a tedious job to do. You don't want to be doing that when you are writing every Python program. So in Python, such things have already been done for you. For instance, the input function helps you to take data from the keyboard. And there are other functions that put it on the screen so you don't do them. Now these modules can be shared. You can also create your own modules that can be shared. That's what I mean by modular programming, facilitating shareable modules. From all what I'm saying, you can also see that modular programming facilitates reusable code. So you create these functions, you keep them there in a library. Whenever you need them, you can pull them out, put them together, and you assemble a computer program or a software. Now let's look at the first part, which is function definition. You define a function by using the def statement. So we'll have a def. Remember the for. It is similar. So this one starts with a def, and then it must be followed by a function name, which is not optional. An open parenthesis, and some things inside it called parameters, which are the inputs into the function, like petrol goes into a carburetor. You close the parenthesis and you have a colon. Then below, every indented line of code is called the function code suite and will be executed as a part of the function until somewhere in the program you get out of the indent, you have left the function. Now let's look at this in more detail. The keyword def introduces the name of the function. This is what tells Python that what you are creating here is not a for loop, it's not a while loop, it's a function. We use def. The function name can be any variable, but it is advisable to use a descriptive variable, something that actually describes what you are trying to do with this function. Parameter lists are optional, so not every part of a machine actually accepts an input. Not every function you create will accept an input. The closing colon follows the parenthesis, and that indicates the start of the function code suite. If you omit that colon, you'll get an error. The function code suite must be indented under the def statement. For example, we have a sample here, def greet user. So greet user is the name of the function. This function does not have any parameters. Under the function, we have a docstring comment that says display a simple greeting. That's just a comment. But what the function does is below, print hello. So the function greet user prints hello. That's what it does. So let's look at an example right away. Function def0.py to demonstrate function definitions in Python, basic definitions. So we define a function and say greet user, print hello. Now we have defined the function. In order to use the function, you must call the function. If you run this program the way it is now, without any other thing included in the code, nothing will be printed in the screen because it's a function. It's a module. It does not work on its own. It is just there like a soldier standing at attention waiting for orders. So what is the order? You call the function. And how do we call it? You just write the name of the function, greet user. That is all. So this greet user is what is now going to print hello. So if you run this program, this is what it's going to look like. We are in Visual Studio Code to actually run the program. Just click on this. It will show you the folder that we have already opened. If you don't know how to do this, go and check out the previous 2 videos to know how to open your directory of codes. So the program was function def 0. Click this again and the window will close. Since this program does not require the user to enter an input, you can just use ARAPL to run it. Let's first of all comment this out to see that the function does not run on its own. You see, print output, nothing is printed out. So even though there is a print here, function is just a standby module waiting for you to call it. The moment you call it, that's when it performs an action. So we print hello. So let's look at some things called arguments and parameters. The first function we saw now did not have any parameter, which is what you find in the opening parenthesis. The variable definition of the function is called a parameter. That's when you actually define the function. When you use the def, that open and closed parenthesis, whatever you put inside it is what we call a parameter. On the other hand, an argument is the value of the variable in the call of the function. So because we did not create a parameter in the last example we saw, we also did not put an argument when we call the function. That's an empty function. It will not always be like that. Some functions will require you to put something, like our input function, our print function. The input function does require you to put something. Okay, so let's see a second example. We want to demonstrate functions definitions in Python by using parameters. So we say greet user. We are creating the same function again, but this time we put username inside. So we say display a simple greeting. Print hello username.title. Then we say greet user Jesse. Take note of this. Because there was a parameter here, there should be an argument here also. Otherwise the function call is going to give you an error. So Jesse is just a variable. I could have said John, whatever you put here, and it's going to print the person's name. I could have put 2 words here, or as many words as I want. So if you run the program, this is what the function does. It prints hello Jesse. So we are back in Visual Studio Code, and that was function def1. Click this again. Array here. Comment this out. See that nothing is printed out. So uncomment the call hello Jesse. If I call it with Jesse Jackson, hello Jesse Jackson. So let's see how to pass arguments into functions. There are several ways to do that. What happens when there are more than one parameters you want to pass into a function? More than one input. When calling a function, Python must match each argument in the call with the corresponding parameter in the definition. This can be a complicated issue. If you pass the arguments wrongly from the way the parameters were arranged in the program, you might have very serious consequences, errors. So one way to do that is called positional argument. Positional argument is based on the order of the arguments provided. Order means that the position in which you provided the parameters, you created the parameters, it is in the same positions that you put the argument. So we call this function def2. We say def describe pet, animal type, pet name. What it does is displays information about the pet. So you say print I have a animal type. My animal type's name is pet.title. We are using the parameters that were defined for the function to do some activities inside the function. So the correct positioning when you call the function will be hamster Harry, in which case it will be I have a hamster, my hamster's name is called Harry. Now if you arrange it like this and say describe pet, Harry, hamster, that will be wrong. Incorrect positioning. If you run the program, this is what it looks like. I have a hamster, my hamster's name is Harry. That is the first call, which is correct positioning. The second call says I have a Harry, my Harry's name is hamster. Function def2. So we open RAPL again. Now we'll comment out these 2 calls, and you see nothing is printed out. If we uncomment the first call, I have a hamster, my hamster's name is Harry. If we uncomment the second call, I have a Harry, my Harry's name is hamster. That is wrong positional argument. Now another way of passing arguments is called keyword arguments. Apart from positional arguments, you can use keyword arguments. So a keyword argument is a name value pair that you pass to a function, and it frees you from worrying about the correct positioning of your arguments in the call. We'll see an example. Function def3. So we still have the same function again. It's not changed. Describe pet, animal type, pet name. I have an animal type, my animal type's name is pet name. It is the same function, we haven't changed anything. The only difference is in the call. So the user knows that the 2 parameters for this function are animal type and pet name, and the user of the function can use them directly in assigning arguments. So the parameter is key and the argument is the value. So the key in this case is animal type, and you just assign it equal to hamster. The second key is pet name, you assign it to Harry. Now, where does this have an advantage over positional argument? It's in the second call. This time around we say describe pet, we call it again, but we put pet name in front. Even though pet name was the second one in the definition, in the parameters, if you are using keyword arguments, you can actually put it in front as long as you assign the correct value to it. So we first put pet name equal to Harry and animal type equal to hamster. Both of them will be correct. If you run the program, this is what you get. I have a hamster, my hamster's name is Harry. I have a hamster, my hamster's name is Harry. Comment this out. I have a hamster, my hamster's name is Harry. Keyword argument, in which case position no longer matters. It's still the same output, which is correct. I have a hamster, my hamster's name is Harry. So there is another way of passing argument in which you need to set a default value. It's important sometimes. You can define a default value for each parameter. If an argument for a parameter is provided in the call, Python will use the argument value provided and override the default value. However, if an argument is not provided in the call, Python will use the default value you provided. Take note that default value parameters must come last. They must come after all the non-default value parameters have been defined in the creation of the function. So we call this function def4. Describe pet. Pet name, animal type equal to dog. So we assign a default value of animal type to dog in the creation of this function. Every other thing is the same. Now in the first call we say describe pet. Pet name equal to Willie. Look at this call. This is the first time we are calling the function and using only one argument, even though two parameters were created in the definition. Why? The reason we are able to do this is because we have already created a default value for animal type, so we can omit it. And Python will automatically take dog in place of animal type. In which case, the output will be I have a dog. My dog's name is Willie. So what if a user wants to override the default value of dog? You call it by putting a parameter there. Describe pet. Harry, pet name equal to Harry, animal type equal to hamster. And the output this time will be I have a hamster, my hamster's name is Harry. That's what you get when you run the program. So we are in function def4. In the first call it says I have a dog, my dog's name is Willie, because that's the default value. In the second call we override the default value. It says I have a hamster, my hamster's name is Harry. All of them are correct. Now passing arguments using equivalent function calls. What does this mean? Positional arguments, keyword arguments, default values, all of them can be combined together in a function call. That is totally legal in Python. So we call this function def5, which will demonstrate a mix of positional arguments, keyword arguments, default values all together in a function call. So we are still using the same function we created last, no difference. We have a default value, every other thing remains the same. So let's call it by using a default value call. We just say describe pet Willie. The other part is taken care of by the function definition. We can also say describe pet. Pet name equal to Willie, that is legal. We can also say describe pet Harry hamster. positional argument. And we can also say describe pet name equal to Harry, animal type equal to hamster. We can also say describe pet, animal type equal to hamster, pet name equal to Harry. That's keyword. And when you run the program, you see everything is producing the correct output for us, as you can see from here. So we will use docstring comment to comment, so we can see the outputs one by one. Nothing is printed because the function has not been called. So let's take the first call. I have a dog. My dog's name is Willie. Come down. I have a dog. My dog's name is Willie. I have a hamster. My hamster's name is Harry. And finally, the last one is I have a hamster. My hamster's name is Harry. So you can see the different types of calls that will combine together, and all of them gave us the same correct answer. No problems. Function return values. So the simple examples of functions that we have seen so far, they only printed something to the screen. Suppose you actually want a function to return specific values. Let's take an example of the quadratic equation problem that we tried to solve before. When you want to solve a quadratic equation, the inputs will be a, b, and c, and the outputs will be x1 and x2. You can create a function to do that, so that somebody just calls the function, puts the value of a, b, and c, and the outputs x1 and x2 are returned, not just printed to the screen. They are actually returned so that somebody can use them in another process. So how do we do that? A function doesn't always have to display its output directly, like we have been seeing printing. The function can process some data and then return a value or a set of value. They can even return a data structure such as a list, dictionary, so on and so forth. So we call that the return value, which is the value returned by the call to the function, and we use the return statement in Python to achieve that. So let's look at a function def6. We create a function get formatted name, first name, last name. What it does is just return a full name, put the two names together, and return a variable called full name .title. Each word, each first letter in the name is capitalized. When we call the function, we can now create a variable to get the output. Musician is the variable we created, equal to get formatted name Jimi Hendrix, and you can print musician. The printing is not taking place in the function at this time, rather it is taking place in the call. We are only printing because we are learning. In reality, you are going to use the value to do something more important than printing. But this is the same way to get something out of the function. It's like petrol goes into the carburetor or some other kind of fuel, and something comes out of the carburetor for the engine to use. So musician is the output that we got from the function. Function def6. Comment this out. So you see, even in the call to the function, nothing is printed because the function doesn't print anything by itself. So we have actually got information, musician, from the function. It's left for us to use the information, and the only thing we want to do with the information at this stage is just print it. So it says Jimi Hendrix. So function return values can also have something called optional arguments. We can use default values to make an argument optional if required when returning values. Look at example 7. We say get formatted name, first name, middle name, last name. Now, why this is important is in different parts of the world, people answer their names differently. You can go to some countries and somebody just has a first name, no surname. You can go to some countries, people who have four names, especially in Latin American countries, 4 or 5 names, a lot of names. So, when you are creating a software that should be global, you should know how to handle it. Suppose you created a function. Somebody has only 2 names, doesn't have a third name. What can you do about that? So we have a function that requests for first name, middle name, and last name. So we say full name equal to first name, middle name, last name. Put them together in a string and title it. Now, if you call the function with the full argument, John Hooker Lee, everything is fine. You can print it. However, if you call the function with only 2 arguments, Jimi Hendrix, for instance, you get an error. Or only John Lee, you will get an error. So, alright, so here's the function. If we say print musician, we call the function with the 3 parameters John Hooker Lee, we actually get a good answer, a correct answer. So suppose you call the function with just 2 parameters, you get an error. So how do you resolve this error? We will now redefine the function in such a way that we can be able to use several parameters. So let me comment this out. What we do is recreate the function by using a default value. We say middle name is empty. See, in the first function we just said middle name, we didn't equate it to anything. But in the second function, we just equate middle name to nothing, which means that it is an optional parameter also. Optional parameter. So we can come and recreate the use of the parameters in the definition of the function. If there was a middle name in the function call, then the full name should contain first name, middle name, last name. Otherwise, there was no middle name. The full name should contain only first name and last name. Then you return full name. If you now call the function with only 2 parameters, Jimi and Hendrix, and you say print musician, it's going to give you the correct output. Now, this one has given you an idea to think about. Suppose the function should also allow only first name. So you need to test whether middle name and last name are included. If they are not included, you make a decision. Before you come and test whether it is only middle name that was missing, and then you make another decision. And you can even test whether no name was included at all, and you make another decision. So I leave that for you to think about. So we ran the function and this is what we got. Since we have been doing these functions, they have been returning simple strings. Functions can actually return complex data structures. So how does a function return a dictionary, for instance? They can return any data type, lists, dictionaries, you name it. We see an example. Function def 8.py. Def build person, first name, last name. Return a dictionary of information about a person. So we start. Person, which is a dictionary now, equal to first name, last name. Return person. So, which are the keys and the values in this dictionary? First is the first key and first name is its value. Last is the second key and last name is its value. Just return person. A dictionary will be returned from this function. If you now call the function musician equal to build person Jimi Hendrix, print musician, it's going to print out a dictionary. So you can also add new data to the dictionary, which depends on the call parameters. So we say build person, first name, last name, age equal to none. In this case, age is an optional parameter, like we saw in the last example. So we will come to test before we return the value whether age has been entered in the function call. If age means was age entered in the function call, if yes, we add another key to the dictionary. Person age equal to age, which is the value that was created. The key could have been anything, but we just called it age. It's a variable. What matters is the value. If it is entered, assign the value to a new key that you just created here. Then you return person. So this function has the capacity to either return just the first name and the last name, or to return a dictionary that contains first name, last name, and age. It's optional. So when we call the function and say musician equal to build person Jimi Hendrix, age equal to 27, it returns the full list: first name, last name, age. You can now print musician. And when you run the program, this is what it looks like. So let's first use a docstring comment to isolate the second part of the function. The first function printed the dictionary exactly the way the dictionary is. So if you see the printout here is a dictionary. That's what was printed out. The raw dictionary by itself with all the key value pairs listed. Now let's uncomment the second function. The second function also printed the dictionary, but this time around the optional age was included. Why? Because the function call included the age parameter. Now we can actually test whether, since the age is optional, if we call the function again, is it going to return with the call with just two values? We'll call it with two values. Now let's call this musician 1 and this musician 1, and we will remove the age in the call, whether the same function works. See? It works perfectly. Now you can use the function in a while loop. You can place it in a while loop wherever you want to place the function in the call. So if you want the function to be called 1,000,000 times, you can just put it inside a while loop. Rather than writing the whole code of the function 1,000,000 times, the function is just called 1,000,000 times. Call this function def9. Get formatted name, first name, last name. The same function we have seen before. Return full name. So we are going to put this function in a while loop. While true, print, please tell me your name. Enter Q at any time to quit. So we are receiving input. Fname, create a variable called fname equal to impute first name. If fname equal to Q, you have to test it, because if you don't, you may remain in this while loop forever. It has crashed your computer. If fname is equal to Q, what do? Break, get out of the loop. Otherwise, go and look for the last name, ask for the last name, impute last name. You still test it. If lname equal to Q, break. Otherwise, call the function. Formatted name is equal to get formatted name, fname, lname. You can now print hello formatted name. So this function actually requires you to enter something from the keyboard, in which case we will not use AREPL, rather we'll run it. Click run. Tell me your name, enter Q at any time to quit. So if I say Ino, last name, okay. Hello Ino, okay. The program keeps running, but we won't go through the loop again. This time around I'll just type Q so that we end the program. So in the last few examples we saw how to return a dictionary from a function, but can you also pass complex data structures? We can pass a list to a function, we can pass a dictionary to a function, we can pass any kind of data to a function. In the same way we can return any kind of data from a function. So we call this function def10. Def greet users names. Print a simple greeting to each user in the list. For name in names, MSG equal to hello name.title. Print MSG. User names equal to Hannah, Ty, Margot. Call. Use the list variable that you just created in the call function. Just pass it directly and it's going to do what the function is meant to do. So here is function def10. We are going to use AREPL because it doesn't require an input. Let's comment the call out so we can clear the screen on this side. See, there is no output. Now if we uncomment hello Hannah, hello Ty, hello Margot. So if you have a list of 100 customers, instead of writing a program to greet all of them one by one, you can just use a function and you call the function in the loop and it does the job for you. So we can actually use a function to modify a list automatically. Inside the function, you pass a list into a function and the list is changed by the function, even though the list was created outside the function. How do we do that? Def11. So we say print models, unprinted designs, completed models. This program is going to simulate the printing of each design until none is left, and we are going to move each design to the completed models after printing. From the unprinted models, we will move them to the completed models list. So we say in the function, while unprinted designs, current design, which is just a variable we created in the function, equal to unprinted designs.pop. Unprinted design is going to be passed in as a list. You can guess the next thing we want to do is append this current design to completed models. But first, let's print out what we are doing so the user can be aware. Printing current design. Now let's do the appending. Completed models.append current design, the variable. We define a second function which will now show us the completed models. We call it def show completed models. In this case, we pass the completed models that had been modified in print models into the new function. So what it does is show all the models that were printed. So we say print the following models have been printed, and we say for completed model in completed models, print completed model. Our two functions are ready. So the program continues. If we now create a list and call it unprinted designs 1, phone case, robot pendant, dodecahedron, and we create a second argument, completed models, which is an empty list. We now call the function. We'll call the function first, say print models, unprinted designs 1, completed models. We can also call the second function show completed models. So we just take the completed models and put it there. Take note that before the second function call, see, we will discover that this empty list was modified in the first function call. First it was empty. What you are putting here is not this empty one. Rather, because you call this function first, this list was modified in this function. So when you say show completed model, it's not going to show you an empty list. Rather, it will show you a list that already contains information that was modified in the first call. Now let's print unprinted designs also. You will discover that this function also modified unprinted design in the sense that it popped everything out from unprinted designs and put it inside completed model. So both of these two lists are changed by this function call. So we see the output of that. Now suppose you actually don't want to change the content of unprinted design. How do you pass the parameter into a function that doesn't change the structure or the content of the list? To do that, we'll create a second list of the same items and call it unprinted design 2. This time around, when we call the function, we'll pass a copy. Rather than just passing it the way we passed it here, we'll pass a copy. How do you pass a copy? We made a copy by using this method that we learned before when we were talking about lists. So nothing before the colon and nothing after the colon says copy everything in the list and pass into it. So while this second call to the function modifies completed models, it doesn't change unprinted design because a copy of unprinted design was passed and not the list itself. So when we say show completed models, if we uncomment this out, it's going to show completed models, and if we print unprinted designs, it's going to print everything that you still have here. The list has not been emptied. Why? Because we passed the copy. Now when you run the program, this is what the output looks like. So we are in ARAPL, and what we are going to do is we'll first comment out the other part of the code. The second call using the second call that uses a copy, we'll comment it out. So let's see the first call. First of all, there are so many prints here, so we want to do some commenting so things can be a little bit less cluttered. So we have unprinted designs, phone case, robot pendant, dodecahedron. The first call was print models, and what that did was print everything that is inside the unprinted designs to the screen. The second function was take note. While we did the first call, both of the lists have been modified. Unprinted design has been modified, completed models has been modified. So if we call the second function that shows the completed models, it tells us the following models have been printed: dodecahedron, robot pendant, phone case. Let's see what happened to unprinted designs 1 list. See, unprinted design 1 is empty because we passed the list directly into it, not a copy. So what the function did was pop everything out from the list and put it inside the completed models. So while completed models now have data, unprinted design which was passed into it is now an empty list. So in the second part of the program, we actually tried to demonstrate how to call using a copy so that the list you pass into it is no longer empty. So we'll comment this out. And what do we have? When we say print models unprinted design using unprinted designs 2, copy of it, it still does the printing. dodecahedron, robot pendant, phone case. By the time we now call, we want to see whether the value of unprinted design 2 has been changed. No. Unprinted design 2 is not empty. It still has phone case, robot pendant, dodecahedron. Why? Because in the call we passed a copy and not the list. So that is the difference. Now there is another issue that can arise, passing an arbitrary number of arguments. Sometimes we don't know ahead of time how many arguments a function needs to accept. What do we do about that? We use a pointer notation. So we'll call this function def12 to demonstrate passing an arbitrary number of arguments in a function. We say make pizza, and then we have two parameters, size, and the second one is star toppings. So we don't know how many toppings a user is going to ask for. That's why we are using this star. All of them are going to be string. So what this function does is summarize the pizza we are about to make. Print making a size inch pizza with the following toppings. So we have a for loop that is going to run through the number of toppings that we assigned. For topping in toppings, print topping. We can now call the argument. Let's try with one. Make pizza 16 pepperoni. We only have one argument on the other side of toppings, one topping. We can also call the pizza by using an arbitrary number of toppings because we use the pointer notation. So we say make pizza size 12, mushrooms, green pepper, extra cheese. You can go on and on and on as much as you like. When you run the program, this is what the output looks like. The first call is making a 16-inch pizza with the following toppings, just pepperoni. The second call is making a 12-inch pizza with the following toppings, mushrooms, green peppers, extra cheese. So we are here in function def12. We will comment out the second call so we can see things one by one. The first call we just entered, for the parameter of size we entered the argument of 16, and for the parameter of toppings we entered only one argument of pepperoni. And what does it say? Making a 16-inch pizza with the following toppings, pepperoni. In the second call, making a 12-inch pizza with the following toppings, mushrooms, green peppers, extra cheese. So that's how to do that. Now the last example we saw is when you have an arbitrary number of strings that you don't know. Suppose you want to resolve the problem of arbitrary number of keyword arguments, like an arbitrary number of dictionaries. How do we go about that? So a function can accept an arbitrary number of arguments, but we may not know ahead of time what kind of information will be passed to the function. It will not always be an arbitrary number of strings. It can be more complex data types. So we can write a function to accept as many key value pairs as the calling statement provides. In this case, we use the double star to collect an arbitrary number of keyword arguments, F13. So we say build profile, first name, last name, star star user info. We are going to build a dictionary containing everything we know about the user. So we say user info is a dictionary now. We create a key and call it first name, and the value is first. We create another key and call it last name, and the value is last. We can say return user info. So we can call the function user profile equal to build profile Albert, first parameter which is first, instinct, second parameter which is for last, location equal to Princeton, field equal to physics. And we say print user profile. So take note, when you were calling the function, you actually created a key value pair. When you run the function, it actually gives you the full dictionary. Location, Princeton, field, physics, first name Albert, last name Einstein. Now, does it not surprise you that in the definition of the function, we only created two key value pairs, first name, last name, nothing else, and we just say return user info. But in the call to the function, we actually updated dictionary during the call to the function, and everything worked out well. Location Princeton. We even included the field, and everything worked out well. So this is function def 13. Let's edit this. And what do we have? Location Princeton, field physics, first name Albert, last name Einstein. So you've created this function. How can you make them available for somebody to import them the way you have also been importing some function? We do that in modules. You have been using modules to import statements, haven't you? Of course you have. So you can store your own function programs in a separate file. We call the file a module. And somebody or you or someone else can import them into your programs by using the same import statement that you have been doing before. So to create a module is very simple. Just copy only the functions into a Python file and save it with a name .py. So let's create a module called module pizza. The first function we put there is make pizza. The same function we had before, we put it there. The second function will be greet customers. You can put as many functions as you like in this module, but everything must be function, no other code, just functions. So after you create the module, how do you import them into your program? The same way you have been importing other modules into your program. Now when you want to import your own modules, but there are some system modules that you need to import, please, it is advisable to import the system modules first. Then you can import your module. When you say import, the module file, the module Python file must be in the same directory as where you are going to use the module to write a Python program. So this Python program is makepizzas.py. Makepizzas should be in the same directory where module pizza.py is located. Of course, there's an advanced way to do that, like all the modules we have been calling in Python, import OS. OS is not there in the program code we are writing, but we are not looking at the advanced way of doing that. Let's make things simple. Keep the module file in the same directory as where your makepizzas.py file is. So we import the module. We can now call the functions in the module by using the name of the module. We can say module pizza.makePizza. We are calling the makePizza function 16 pepperoni. Module pizza.makePizza 12 mushrooms, green peppers, extra cheese, which we have done before. You can also call other functions. If we say create a variable and say names equal to whatever we have here in this list, and use the list in the call to the module pizza.greet customers names. So when you run the program, this is what the output looks like. So we are going to comment out some part of it to make our understanding easier. Right. This is the first module call. Make pizza 16 pepperoni. Making a 16-inch pizza with the following toppings. I'll move this down a little bit. Make module pizza.make pizza 12 mushrooms, green pepper, etc. The output is making a 12-inch pizza with the following toppings: mushrooms, green peppers, extra cheese. Come down a little bit more, and then we'll create a list called names, and we'll pass the list into the call to greet users. Module pizza.greet users names. And what do we have? Hello Ada, hello Ola, so on and so forth. So there are various ways of importing modules in programs, elegant ways to make your coding, your typing to be reduced. You can use the as word to give a module an alias. For instance, instead of just saying import module pizza and every time we call the function we have to type the whole of module pizza, you can just say import module pizza as p. In which case, you don't have to say module pizza.greet customers when you call it. Rather, you just say p.greet customers. This has an advantage. First of all, you have less typing to do. And if you calculate how much time it takes you to type 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, you are reducing your work, your typing work by a factor of 11 if you use only p as the alias. So if you need to call this function 1000 times, you can calculate how much time you save. It's more efficient. Not only that, when you type a lot of letters in your program, you are using more memory of the computer. So if you do less typing, you use less memory, you save more space. It also helps to make your program run faster. Let me give you this analogy. If there is a house, a big house that contains 10 rooms, and I ask you to go into the house and look for an item that I don't know where it is somewhere in the house, then there is another house that has only 2 rooms, and I ask someone else to go and look for an item, I don't know where it is. What do you think? Who do you think should get the item faster under normal circumstances? Remove a stroke of luck out of it. The person that has bigger rooms to rummage through will spend more time looking for the item than the person that has only 2 rooms. So that's what a lot of typing does to your program. When the code is very long because of a lot of typing, the program can be less efficient than the one that has the shorter code. So we can also say p.makePizza 16 pepperoni. That's one way of doing it. You can also use as to give a specific function in the module an alias. For instance, you can say from module pizza import makePizza as mp. So when you call the function, in fact this is even shorter, you just say mp 16 pepperoni. You can also import specific functions from the module if you don't want to use all of them. Some modules can be very, very large. They contain a lot of information, a lot of functions, all of which you don't need. If you know the exact function that you need, you can import that specific function. For instance, you can say from module pizza import greet customers. We've seen the example before. You can even give it an alias. You can also say from module pizza import greet customers make pizza all the functions that you want specifically. This also makes your program more efficient and makes it to run faster. So in that case, you don't need to say module pizza.greet customers. You can just say greet customers. Better still if you use an alias. You can just say greet customers as GP. So you just say GP names. Okay. You can equally import all functions in the module if that's what you want. If you think that is efficient for you, it's okay. In that case, you just say from module pizza import star. This is actually equivalent to say import module pizza. So let's look at styling functions. An advice for writing functions. Functions should have descriptive names using lowercase letters and underscores. We've seen that in all the example functions we've created. Every function, it is advisable that it should have a comment that explains concisely what the function does, so that in 3 years time when you are looking back at a program which you wrote, you don't get confused. And when there are people that need to upgrade or update your function, for instance you are working in a company, some people are getting old and retiring, others are coming in, and then they still have to maintain and upgrade the software that they are using. So for the purpose of upgrading the software, it is good for you to use comments to explain the codes to those who are going to upgrade it in future. For a default value parameter, no spaces should be used on either side of the equal to sign. Take note of that. This is not an advice. It is a law. So we have come to the end of the class today, and the main bibliography still remains the book of Eric Matthews, Python Crash Course. Please like, share, comment, and subscribe for more videos. Thank you very much, and see you in the next class.